I am muted.
I let the mutes fly, guys. I hope you don't mind.
Oh dear. No.
I mute like at will. It's not like I don't mean to be rude or anything. If of course, if you have a question, you should unmute yourself and ask. I won't mute you if you if you have a question. All right, I see already someone in the chat. Okay, great. Yeah, and you can put. I've got everything available. So if you put something in chat, hopefully I'll see it pretty quickly. And if you're like shy about vocally saying something, but if you want, if you want to say something, feel free to do that too.
Honestly, don't. So I thought I missed it. Hit it right there. Shane.
Yeah.
Oh. Didn't do it at first. Nice. Yeah. I should have had that lock. Can anymore.
Okay. I don't know who that is. I can't, for some reason, I can't identify. Double check to see if you're muted, please, everybody.
But that's new.
All right. Okay, guys. So it's time. Let's talk for a minute. Will this be uploaded on Canvas is a question by Paul Doe. Yeah, I'm gonna after I'm done, I'm gonna upload it to YouTube and then to Canvas. Have a little post-production time lag that takes between 10 and 30 minutes, depending on if other things are popping up in my world. So I'll try to get it up as quickly as I can tonight. I know people will want to look at it. Okay. All right. Uh-oh, I'm getting a little feedback here. Let me, okay. All right, so I think maybe someone is not muted, and I'm hearing them. Please mute yourself, everybody. Okay, I don't hear my echo. Okay, good. All right. As host, I can force mute to everyone. Yeah, it's been a while, guys. Thank you. That's probably true, and I have not. That is, I'm sure, quite true, but I don't know where to find it now. Thank you for. I can do that upon sign in, but I'm sure there's a way of doing it like retroactively. I didn't see where to do it. Anyway, I'm just going to not worry about it. But thanks, Sam. Okay, so let's start the review. All right, so I promised in lecture to say kind of what formulas I want people to know. And so I'm just going to go over those really quickly at the start. The first one is kind of the first one we hit with the dot product. So formulas, and these are the ones that are not on the formula sheet. So formulas to know. One would just be, if I have two vectors and I take their dot product, then this is equal to the product of the norms, or the magnitudes of the vectors, times cosine of the angle between the two vectors. That's one. You should know that. We use these things so frequently that I don't want people to have to resort to looking them up later on. Another one would be the area of, well, maybe this is just area of parallelogram spanned by U and V, meaning it has sides U and V. That this is equal to norm of U and V. And, you know, I don't think I ask you to know this specifically in the exam, but it, you know, this comes from this fact that this is equal to the norm. It's equal to the sine of theta times the magnitudes, product of the magnitudes. Okay, so that's another one that, you know, you should feel good about. Similarly, volume of parallelepiped spanned by 3 vectors, say U, V, W, this is equal to, well, you take, there's an absolute value sign depending on the orientation. So you might get a negative if you don't take absolute value. But you dot product, it's called the triple scalar product, and you dot product the cross product of 2 of them with the third. It actually doesn't so much matter which order you take this in, as long as you take 2 of them, take the cross product and dot it with the third. You should know how to find the distance between a point and a line. Okay, so I guess we can give ourselves some, let me give myself, so I'll call the point, I think the book, I think if I remember correctly, calls the point M in their formula, and a line with, so whenever you have an equation for the line, you should be able to find a point on it just by putting, these are parametric equations, so you put in a value for your parameter and you'll get a point on your line. And then also find the direction vector by looking at the coefficients of your parameter. And you can get a direction vector. So let's say we have a line with point P on it and direction vector V. So if you have this information, then you have a formula, and the formula is the distance is equal, well, you take PM, take the displacement vector from P to M, and you cross product that with V, and you take the magnitude of that, and then you divide that by the magnitude of V. That will give you a formula for the distance between M and the line containing P in the direction of V. And this was, I mean, I went over in class why this is the case, but so I'm not, I mean, unless people want me to, I can, I'm not going to go over that again. And then the final, so, okay, so how many do we have so far? So we have 1, 2, 3, 4, and I think one more that you should kind of have in your arsenal here is the distance between a point and a plane. Point M, so I'll call it M again, and a plane with point P in it and normal vector N. And for that, I mean, the idea of that is you can take then the displacement vector from P to M, and you can project it to the normal vector. And then the magnitude of that is going to give you your distance. So one formula for that would just be what I said. Namely the projection to the normal vector of this displacement vector. And that might be easier to remember because there's a formula for the projection on the formula sheet. on the exam. But if you don't want to do that, we have a formula for the projection vector, and that will just be, well, so we have PM and we have PM dot n over norm of n squared times n. This is the projection vector, but we're taking the norm of it. And so when we take the norm of it, well, so this, you don't need to remember this derivation, but I'm just kind of showing you why the one in the book is the same as the one I'm telling you. Whenever you have a scalar times, this is a scalar, it's a dot product, so it's a number. Whenever you have a scalar times something, you can bring that scalar and you take the magnitude, you can take that scalar out, but you just have to put an absolute value on it because you're sort of squaring it and taking the square root. So you're going to take an absolute value, and that will just give you PM, absolute value PM dot n, and then you've got a norm of a magnitude of n over the magnitude squared. So you can just divide. This will give you, so this is, I think, what you'll see in the book. This formula here. So this, but I think this is basically it. I mean, so as far as memorizing like formulas to give you numbers, you should know techniques, of course, of how to find equations for planes and lines, and how to manipulate things, take limits of vector valued functions, that kind of thing. Any questions about that stuff? Nobody? Okay. All right, so let me then I only got one, to be honest, I only got one eye-mail, unless some people have just like emailed me real recently, which I don't think they did. Yeah, I only got one email concerning like asking me to go over something, and I'll go over that. But then I'm not sure what to do unless people have questions, and then if they have questions, I can answer those first. I'd like to do that first. And then otherwise we can just look over the practice exam. So Sam is asking, or sorry, I didn't mean a direct message to me, sorry. Someone is asking how to find the normal vector to a plane given the equation. Okay, that's a good question. And let me, I'll actually address that question first, because I think that's not too bad to take care of. So, I'll write an equation. I'm going to write an equation, kind of a silly looking equation. Let's say, so here's a plane. So let's consider this plane. Z equals y plus 2x minus 1. That's an equation for a plane. It's not in the standard form that we usually have it in, but it's an equation for a plane. So this is the problem. So find a normal vector to the plane. Okay. So solution. So the way you go about this here is first I would put it in so-called like the standard form. A standard form, there are a couple of forms. You can think of it a vector, but I think the most standard form that you can look for is something of this type. Let me just write it in the general type. AX plus BY plus CZ equals D, where here A, B, C, and D, these are numbers. Okay. So put whatever kind of formula, I mean, if you're working on it and you have it in a problem, put it in the standard form if you're asked to do something like this, or if you need to do something like this to get an answer to some other problem. Okay, first do that. So if we put this in the standard form, we'll get negative 2x minus y plus z equals negative 1. Once you've done that, and really do that first, then you can easily identify a normal vector. And it's just given by looking at, to find the x component, you look at the coefficient of x, negative 2, y component, coefficient of y, negative 1, z component, coefficient of z is 1. So a normal vector here is -2, -1, 1. Okay, let me just say n. That's it. Nothing, I mean, nothing magical. That's it. Now, why do I keep on saying a normal vector? Because of course you can multiply this equation, the entire equation, by a constant, and that will multiply your normal vector. So you can definitely do that and you'll get a correct, I mean, normal vector is just a particular direction. It doesn't have to be a certain length. Okay, so that is an answer to that question. I hope that helps. I have another question which asks, what format do I want parametric equations in? It doesn't matter to me, to be honest, as long as it's clear. And so if I ask for an equation for a line, I just want an equation for a line. I will probably be talking about a parametric equation of some form. So if you want to do the vector parametric equation, that's fine. If you want to do the parametric equations where you write x, y, and z individually, that's fine. And I will, the person, whoever is grading that particular problem, before we grade the problems, we all get together, all of the GTAs and myself, and we discuss. And there's some instructions that go to everybody, and one of them will be precisely that the type of equation, type of form of equation is pretty much up to the student, as long as it's one of the forms. So it doesn't bother me. So in particular, like for this question, so if I give you the problem, like find an equation for the line between 2 points, say, I don't know, 1, 2, 3, and 3, 2, 1. All you need to do, I mean, so the solution here, take the difference, find this, let's say I call this P and I call this Q. Take the displacement vector, PQ, right? That's going to be 3 minus 1 is 2, 2 minus 2 is 0, 1 minus 3 is negative 2. This is a direction vector. And then for me, it's easiest, once I have that, I can immediately write a vector parametric equation just by saying, okay, take the initial vector at P, ending at P, which will be 1, 2, 3, and add T times my direction vector that I just found. Now, I would prefer it, I probably would give full credit to this answer. I think this was actually pretty much fine, but maybe it's a little nicer to kind of make this into one, something like this. I think this may be a little bit preferred to actually have a single kind of vector. But again, I would probably be fine with, as long as you're identifying the right, like a direction vector of the line and a point on the line, and you can put it into this kind of an equation, I think that's pretty much full credit. So this form is fine, but if you are more comfortable writing the X, Y, and Z, and again, you don't have to put T here, you could just put X. this is fine too. So you can do it this way. I'm fine with you doing it this way. Those are all fine with me. Okay. But then, at the end, try to kind of box off your answer, whatever it is. If you write R of t here, box it off here. Okay. Good. I'm getting a lot of questions now. That's good. I appreciate that. Okay, there's a follow-up question. There's a follow-up question on the normal vector point, which I'll just address. Normal vector point said, what if I chosen the negative of this? What if I had chosen the negative of this? Well, that's fine. It's still a normal vector. The question then is, what if I applied that to the plane? Do I get the same equation? You don't get the same equation. What you'll get if I took the negative of this equation is I would get this equation. I would just get negative of everything. I'm losing it here. Okay, yeah. Sorry, this should be plus. I would get this equation, which is equivalent. I mean, I can get here from here just by, instead of subtracting this to both sides, I can subtract z and add 1 to both sides. So you can multiply this equation by any constant, and if you do the same, on the right and the left, you're going to get an equivalent equation, and that's analogous to changing the normal vector by a scalar. So you'll get the same kind of thing. And of course, all of these are legitimate equations, so we'll accept these equations if they're correct. Okay. All right, you guys are great. So many questions now. All right, so I'm going to ask you guys the following for the next review session. I would love it if you guys could send me some of these in an email ahead of time, because then I can write them out, and then I know that I can go over them and maybe prepare a few more detailed kind of examples or problems. But okay, that's all right. I don't mind. We'll figure it out. If I have time, could I go over the different types of graphs for vector valued functions, such as how do we tell the shape or surface? I'll instead of addressing that question, I'll say that I'm not going to ask you to graph a vector valued function. How's that? Right now. Later on, when we get a little bit later in the course, we may have certain things where we want to parametrize the boundary of something in 3 space. And then it might be a really good thing that you know how to do that, or what parametric equation will give you that graph. But right now, I'm not asking anything like that on the exam, so I'm going to avoid that one. However, then I have another question that asks about traces, and what are we expected to know on how to visualize and describe it, and how. So I do have some question on that in the exam about traces. And so you should expect it. The exam, I should have mentioned this in the beginning here. The exam itself, I did trim down a little bit from the practice exam. I think there's only 5 questions versus 6. I kind of got rid of a part. So I lowered the amount because I was a little worried that people would run out of time. So I lowered that amount, but it's very similar. It is not the same, but it's very similar to the types of questions I asked on the practice exam. And some of them are a little easier, some of them are a little harder, but it's basically the same level. Now, as far as traces, so let's look at an example. So let's consider the following quadratic surface: x squared minus y squared minus c squared equals 1. Let's just do something really basic. And then we'll say find and describe. Or I think the phrasing I use on the practice exam is sketch and describe. And we'll give you two different possibilities. Let's say the z equaling z equaling 2 trace and the x equaling 2 trace. Let's say I did that. So these are two different problems. So what I would want from so there are two parts to this problem, right? I'm giving you two asks. One is to sketch something for me. I will never have you sketch anything in 3 dimensions, okay? I'm not asking you to give me a 3-dimensional picture because that's just, that takes practice and everyone's kind of bad at it at some level, except really good artists. So I'm not asking you about your artistic ability. But I will ask for you to draw some 2-dimensional graphs of things that you should know. And I know that there was some negative, like some people had said they hadn't had experience with hyperbolas. I heard that, so I probably won't put that on the exam. But other things I think you guys will feel comfortable with, I want you to be able to sketch them. But in this case, this particular problem, if we take a look, we'll see that we get for A, x squared minus y squared is equal to 4, or minus, sorry, I put in the z equaling 2 value as 4 equals 1. I can rewrite this equation, x squared minus y squared is equal to 5. Okay. So while I might not ask you to draw a hyperbola, this one, you do get a hyperbola. And so what I would want for an answer, in theory, is I would want someone to give me like a 2-dimensional, label your axes, x and y, and then kind of decorate it to your heart's content, but get the general shape correctly. Okay, that's kind of when I'm looking for a sketch, I'm not asking for, you to exactly align with the asymptotes or any of that kind of stuff. Just give me the general shape. I think that will get full credit. And that will be kind of the instruction. So in this case, we'll get a picture that looks like this. If you want, you can decorate it with certain points. You can say, okay, here I've got square root of 5, 0. Here I've got negative square root of 5, 0. You can impress us with your great knowledge of these things if you wish. But do write, it's a hyperbola or just hyperbola, right? That's the describing part that I want, is I want you to say, okay, well, what is this? This 2-dimensional thing, or this graph of a 1-dimensional thing, you'll know. That won't be a mystery to you. So that would be an example. And then if you did the x equaling 2 trace, well, what would you get? You would get 4 minus y squared minus z squared equals 1. And so I could add y squared plus z squared to both sides, and I would get 5 equals y squared plus z squared. And you all know what that is. But again, give me a little sketch if you could. Label your axes, y and z in this case. And I don't know. Okay, so it's a circle. Here, maybe you could say, circle of radius square root of 5. Oh, wait, did I mess up? I did mess up. I have 4, I need to subtract. This should be, I didn't do my arithmetic. I need to subtract, not add. This should be 3. Sorry, I had a feeling there's something wrong. Okay. Yeah, I got partial credit. Try to look over. I mean, something that I've gotten in the habit of for my long life of doing math problems is, I'll make a mistake, but at the end I try to look at it again, and oftentimes I'll find the mistake if I do that, because just, you're doing things quickly, you miss things. Okay. So that's kind of, I'm not going to ask things that are much harder than what I'm just showing you right now at all. So this is basically it. Someone asked, for the exam, are we just going to do our work in our notebook and turn in the notebook? No. Okay, so the exam will be, if you look at the practice exam, it's just like that. There'll be space for you to write your answers. I want you to show your work, okay, and just hand that in. If you need some extra scratch paper, you can include some extra, you can put some extra scratch, but there should be enough room in the exam. It's 10 pages and there's a lot of space in there to write. So try not to write too large so that you have enough room, but there should be enough room to answer all the problems. So just hand that in. There'll be a little labeled place to put, when you're done with the exam, to put your exam in the stack for your particular recitation section. So just go up and hand it in there. But yeah, you won't need anything except a pen or pencil or whatever. You should be fine with that. What else? When else are projections used besides, or between a point and a plane, besides between a point and a plane? Projections are used actually very, very frequently in applications, but I think you're asking about for like questions that we might have on the exam. I mean, I might just ask you a question of like, here's a vector and here's another vector, project one vector onto the other. But this question is actually, I want you to take a mental note because, well, I wrote the exam, so let me try to give you a little hint going in of something you should know. I am the kind of mathematician, the kind of person that really values concepts and understanding concepts more than I value computation. So what I want you to know most of all, I want you to understand have some of the formulas in your head. I do want that, but I really want you to understand what it means to project one vector onto another. And so having that understanding will help you on the coming exam. So if I have a vector, v, and I have another vector, u, what the projection of v onto u is, this is some other vector, right? You all know this is some other vector. And what it is, it's that vector that points in the direction of u that will make a right triangle with v. So it's that other vector, which I can't seem to get. Let's see, it's this vector, right? And it goes just to that point so that when I drop this down perpendicular, I get a right triangle. Okay, that might not be perfectly right, but hopefully our perfect right angle there, but you get the idea. That's the vector that is the projection. It's that unique vector that will give you that right triangle. Okay, keep that in your mind. I think if you keep that in your mind, you'll have a big hint for one of the problems. Some problems I'm not asking you to do something hard computationally, but to understand the concept. Okay. Well, I go over a tracing problem. Hopefully that helped, the one I did go over. Will there be a lot of questions on quadrics? There will be almost no questions about there will be no questions, 0 questions of the form, identify this quadric. Is it an, hyperbolic paraboloid, or is it, what is it? I won't ask that. That's not something I'm going to ask. So I don't need you to memorize any, of the types of quadrics. However, I might give you a quadric like I did in this tracing problem and say, give me a trace of this thing. So that's kind of the types of problems I'd ask on quadrics. Will the practice exam still cover the same concepts as the real tests, even if the questions are different of the real test? The same concepts, yes, the same concepts. Yes, the written practice exam, written practice, the one that I wrote is the written practice exam. The online one is to kind of help you with some more computational stuff, which some of that will be on the exam too. But I try to keep the written practice exam and the actual exam very close in how they're structured. Okay, I'm going to skip the graph question. There's some people asking about different problems. Okay, yeah. There's some people asking some questions that I might skip here. I haven't addressed the one that was the email ahead of time, so I wanted to do that because I think it's relevant for the exam, and I think a lot of people struggle with this. So let me address this. The question was, how do we deal with spherical to Cartesian, Cartesian to spherical, those types of problems. So let me give you a sample problem of that nature. So problem. Using spherical, spherical coordinates. I can't spell it all right now. Coordinates. Describe the part of the unit ball centered at the origin. I'll say centered at the origin. I won't use this kind of language on the exam, but I'm just using it here just because it's easier. I'll explain what I mean here. For which XY is in, I don't know, so I'll say the third quadrant. So the unit ball, when I say the unit ball here, what that means is it satisfies the inequality, this inequality. That's the closed unit ball right there. Satisfies that inequality. And if I wanted to say in inequalities, the third quadrant, well, for X and Y, so we're still in three-dimensional space, but we can still, look at the X and Y. So this is the third quadrant here. And what we know about the third quadrant is this is where X is negative and Y is and Y is negative. Took me a second there. So we know that. So if I didn't want to use all this language, I could have just said, here are these three inequalities in Cartesian coordinates. Describe them in spherical coordinates. So, well, if we wanted to answer a question like this, we can take a look at this first inequality, and it should be pretty straightforward. The first inequality should be pretty straightforward, right? We have rho is equal to the square root of x squared plus y squared plus z squared. It's the distance from the point to the origin. So this first inequality, we just have in spherical coordinates, gives rho is less than or equal to 1. We take the square root of both sides. So that's one, we've taken care of that inequality. Okay. Now the question is, what about, we should get some other inequalities involving theta and phi, or phi, if you like. So there's a couple of ways of going about this, and I'm kind of struggling which way I think will be easier for everybody here to understand. The way I understand it, or the way I look at a problem like this, is I look at this object and I ask myself about the bounds for these other variables. And I think, if I have, so I'm just going to explain this, but, I have this, what this describes is sort of like an apple or something, wedge, right? It's like, it's a part of the sphere that's been cut out. So if I have a point here, if I have some point in here, what is the phi value? Well, the phi value is that angle with the z-axis. But what I know is there's no real constraint on phi if I have that point. In other words, if I just change phi, then I'll just be kind of sweeping out this region here. So I see no constraint on phi. Phi can, be whatever it wants to be. So that's kind of how I see this, is I see this as phi is unconstrained, which means that it's just lives within the bounds. And this really may not need to be written, but it lives within the bounds given by spherical coordinates. On the other hand, theta has a bound, and theta is this, and the thing about theta is the same theta that is there in cylindrical coordinates or in polar coordinates if you were to project to the XY plane. So theta is going to be this angle made with the positive x-axis. And here I can see precisely what this third quadrant is relative to theta, right? Theta has to be greater than pi and less than 3 pi over 2. That describes this whole region for theta. So I just see that geometrically, and it makes sense to me that these are the reasonable bounds for theta. So this is how I would approach this, and this indeed does give you the solution. Alternatively, so if you didn't like that, and I think maybe some people won't like that, what you could do is you can use the change of coordinates formulas. So you can say, okay, well, x is greater than or less than 0. So you know that rho times sine of phi times cosine of theta is less than or equal to 0. That's equal to x by the formula for spherical coordinates, the change of coordinates. And these formulas, by the way, they are on the formula sheet at the end of the exam. So you'll have them available. You don't have to memorize these. So you have these two inequalities. And now, but the problem is how do you go from this inequality, these inequalities, to this inequality? Well, for this, I would say you just have to think for a minute. Just have to think. How can we make these simpler? Well, the first thing we can do is we can just take them by themselves. So let's forget about x and y for a moment. We've moved over to spherical coordinates. The next thing we can do, which is quite easy to do, is we know rho is non-negative. If rho is 0, fine, it's 0, it's allowed, but otherwise it's not, it's actually positive. And so in either case, we can kill rho because it's non-negative. If you divide by a negative number, you have to switch the inequality, but here we don't because we know rho is non-negative. So rho is non-negative, so this inequality here is the same as this inequality here, and same with the y inequality. But now we know something else, and this is something I'd like everybody to kind of pay attention to for a moment. phi is constrained to be between 0 and pi. Phi is constrained by just for spherical coordinates, it's stuck in that interval. You don't get to consider it outside of that interval for spherical coordinates. So what is this sine phi? What is that when we have only 0 to pi? Well, we all remember the graph of sine, and it goes like this, right? But this is 0 and this is pi. This is sine phi, sine theta, sorry. Well, actually, no, I'm using sine phi. Phi is the parameter. So in this interval, 0 to pi, sine phi is positive or non-negative. So in that interval, whenever for any phi we're considering, this is non-negative. So we can kill it too. And now we have two inequalities, cosine phi and sine phi, cosine theta and sine theta, and we're asking them both to be negative. And we know theta has to go between 0 and 2 pi because theta is constrained in that range. So I can just erase this this graph, and I can put sine theta, and then I can put I don't know, cosine theta, which you all know and love, right? And looks like that. And I can ask when, so this is cosine theta, and I can ask when are these two functions both simultaneously negative? And there's only one little area right here from here to here that they're both negative. And this is pi, and this is 3 pi over 2. And so that's why I get this inequality for theta. How do people feel? Hopefully no one's like started throwing up yet. No, there's no reaction. Okay. That was much worse. Okay. All right. Anyway, there are many ways to whatever you do with cats. And apple slice is better. Okay, good. Yeah. I like the apple better too. I mean, I like kind of visualizing it and then using that, but you want to make some explanation. So certainly write down, I mean, if you get the right answers, we'll assume that, we'll probably feel much better about your answer, but especially when there's a part of the problem that has to explain, but even if there isn't, we do want to see some explanation of why you're getting what you're getting. So at least write out what the argument is or why it is the way you think it is. Okay. All right, great. All right, so someone asked a question, which is a good question. When we are looking for the angle between two vectors, what you're going to do, of course, you're going to find a dot product, but then the problem in the practice exam asks to find cosine of theta, because I think it's like square root of 3 over 3 or something. I mean, something that without a calculator, you're not going to find the actual angle or even an approximation. So, but I think on the exam, I do ask for theta. So if you don't remember your trig, your basic trig. So for example, if I had cosine theta is equal to square root of 2 over 2, okay, and you don't remember that this is, that means that theta is going to be pi over 4, then you can say theta is the angle for which this is true, right? Okay, you can do it. You're not going to get full credit, but we'll know that we'll know where the problem is, and that's okay. We all have like little weaknesses. So if that's something, if you get a number and you're like, I know I should know this, but I don't remember, it may be better not to guess. It may be better just to leave it. So have some confidence in your response. But this may have like a point off or something if you had like a 5-point problem. I don't know. We'll be generous, but try to have that. So if you give the answer in degrees, shame on you, but you'll probably get full credit. Someone asked, can I do it in degrees? I mean, come on. This is a math class. I don't know. I mean, we're not sailing a ship here, guys. Or maybe we are, I don't know. Okay. All right, so some people had asked some questions about the exam, like, can I go over one of the questions on the exam? Explain number 4 on the written practice exam. So let's see here. I'm gonna stop share for a second and see if I can't get that problem, get the practice exam pulled up here. So all right, I got it. All right, so let me I can share screen. I imported it. What happened? Oh, there we go. Okay. So this is a practice exam, and someone asked about problem number 4, which is, I don't remember what it is. It's this. Spherical. Yeah. Okay. So this is also, this is the unit ball, right? Right here, this guy. And we're saying Z is non-negative. So Z is, we think of it as positive. So we draw a picture. I always like to draw a picture. This is what I do. But again, you don't have to do this. You can just use the equations. And then, you have this kind of upper part of the sphere. Okay. So it's this upper part. And now I look at the two inequalities and I want to identify sort of where they are relative to the spherical coordinates. And this inequality we know is very simple. It's the same as what we did just a moment ago. We'll get rho is less than or equal to 1. Now, if you think about the sphere or the upper half sphere, what you'll see is that it is rotationally stable under rotation around the z-axis. This is the z-axis, which means that if I rotate it there, I'm going to get the same thing, which means if I have something with an angle theta and I increase the angle theta, keeping everything else the same, rho and phi in particular, then it will still be in there. So there shouldn't be any constraint on theta. Theta is independent of this shape. Whatever, in other words, if I have something in there that has a particular theta and I change that theta, it's still in there. If it's not in there and I change the theta, it's still not in there. So theta has no constraint. So that leaves one variable left to constrain, and that's the phi variable. And again, we should think about what phi is telling us. If I've got some guy here, point in here, and it has this angle phi, well, phi is, I'm allowed to kind of take that point and bring it down until it hits the XY plane. And when it hits, so in other words, phi is sort of, I'm allowed to move phi all the way from 0 all the way down until it hits the XY plane. And what is that angle that I get when it hits the XY plane? Well, it's still that angle that's made with that z-axis, but now you can see that's a right angle. It's pi over 2. So the phi constraint should be phi is less than pi over 2. Is less than pi over 2. Of course, phi is still greater than or equal to 0. That's just part of the constraint for phi as a spherical coordinate. If you don't like that, if you don't like that geometric argument, you can use the actual change of variables formula and just say, okay, look, rho cosine phi, that's z. And that has to be positive. This is a little easier than what we did last time. I can divide both sides by rho, and I get cosine of phi is positive. And then I take a look and I remember, for phi, my range isn't 0 to 2 pi like theta, it's from 0 to pi. So I look at the graph of cosine. if I can draw it, my axes. And for cosine, we know that we get this graph that looks like this, at least from 0 to pi. And the place where cosine of phi is positive goes from 0 to pi over 2 in that range, for that range, for that domain, I should say. So that tells us that this is what we would want. Okay. Okay. So there was another question from the practice exam. People wanted me to cover 1F. I don't remember any of these. I mean, I have some recollection of. Find the distance between the point 1, 0, 0 and the plane parallel to U and V, which passes through the origin. Parallel to. Okay. So I want to say something about question 1, because there is a question 1 analog on the actual exam. Question 1 is designed to build on previous answers. When we grade, I believe 2 people are grading question 1. Well, the person that grades the second part will be instructed to look back and see if you got like the wrong answer to something earlier and the next question builds on it, you shouldn't be penalized for building on the wrong answer. We're looking for this next step. So this is one of these types of questions. And I don't remember, so maybe someone can help me by looking at the solution set. I don't remember, what did we get for U cross V? Could someone tell me, or? I mean, I guess we could calculate it if you wanted, but I'm just trying to, in the interest of time. Maybe someone's writing it. 1, 0. Okay, thank you. Okay, so this is what we get for U cross V, and an F is going to use that. And I really want you guys to know this. There are problems like this on the actual exam. Do not redo what you already did. In fact, some of them are set up to use information that you've already calculated so that you don't have to redo it. Okay, so look, when you're doing part F, if you say, oh gosh, I have to take another cross product, you might not have to. Just look back and see if you already took that cross product. Okay, really, it'll save you time. And this is why it's written to be that way. It's written to save you time. Okay, so find the distance between this point and the plane parallel to U and V. So if a plane is parallel to another plane, it has the same normal vector, or it has its normal vector could be a normal vector of the other plane. Their normal vectors are parallel. So that means I can use n as a normal vector for the plane, n equaling, 1, 0, minus 1 as a normal vector for this plane. And I know, so what do you need to find the distance between a point and a plane? You need the point, which we have, 1, 0, 0. You need a point on the plane, and you need a normal vector. So we have a point. We have a point on the plane because we're told it's passing through the origin. So the point 0, 0, 0 is on the plane. And we have a normal vector now. So we have all the ingredients, and we can just look at the formula if we want, or look in our brain in the formula and figure out what it is. So we need to calculate a displacement vector from a point on the plane to the point that we're trying to find the distance to. So, So the displacement vector, it's kind of a silly vector. It's one of those standard, not standard, it is a standard vector, excuse me, from 0, 0, 0 to 1, 0, 0. This is the vector I, but it's just, it's 1, 0, 0. And now the formula that we have is that we take this displacement vector, we dot product it with the normal vector, and then we divide by the norm, or the magnitude of the normal vector. And that gives us, and take the absolute value. So if we need to, right? So the distance, by just using this formula, this is equal to 1, 0, 0, dot 1, 0, minus 1 over, and again, you can, in this case, you don't need to take absolute values, but here we will. So we get 1 over the square root of 2, or square root of 2 over 2. That's it. Someone asked, in the spherical coordinate problem, are we just saying what the spherical coordinates could be? So if we look back at this, these are bounds, and these bounds, they describe a region. And so yes, we're saying that if you're in that region, then your coordinates are bound by these inequalities. They can't, rho can't go above 1 in order to be in this region. And phi can't be greater than pi over 2 if you're in that region. And furthermore, if these two inequalities are satisfied, you are in that region. This is a lot more important than some of the problems asked in the book homework where they just say describe the surface, describe an equation, because although that also, if you satisfy the equation, you're on that surface. And the reason for this is because one of the main reasons we want to use spherical, cylindrical coordinates, polar coordinates, is to integrate over regions. And we're going to need to change the domains of integration when we get there. So these types of problems are really designed to help you later on in the course. We're not just going to do this and then never, and forget all about it. Unfortunately, maybe for some, I don't know. Isn't the magnitude squared? I don't believe so. No, the magnitude shouldn't be squared for that formula because we're dot producting on the top. I think you're thinking of the projection formula. When you take the magnitude of, so I think the confusion, someone asked, isn't the magnitude squared? So if you look at projection, I did say this, so let me clarify. So if I project onto the normal vector, say P, I don't remember what I use, PM or something, and I take the norm. So in the formula for projection, you will get a square in the denominator of n. That's true, but then you also have that you've got the vector n in there, and so you'll take the norm of that, and there'll be a single cancellation. So then you won't have a square. It should, and another reason that you should expect this formula is that if you can, as I said, normal vectors aren't unique, so you could scale them. And so if you scale this by a factor of lambda, this will also scale by a factor of lambda. And scaling that normal vector shouldn't affect distance. If it were squared, it would affect distance. Okay. Someone asked, if a variable is unconstrained in these inequalities, do we need to write it? It's not necessary, but you could. If you want to write it, it's fine. You certainly won't be penalized for writing, that theta has to be between 0 and pi over 2. Like that won't be, no one's going to say, oh, no, don't write that. Like it's fine. So, but I don't think it would be required because if it's not stated, then there's no constraint. Just like if you look at the problem here, yeah, I don't say anything like, x is between, infinity and negative infinity, right? X is whatever x needs, can be. So I guess, but it's up to you. If you want to write it, I certainly won't, it won't be a problem. On 6b, Okay, someone asked a question about 6B. Oops. So I'm going to be honest with you guys. So as I said, I cut out a problem from the exam, shortened the exam slightly. I modified, our testing schedule is set up by room coordination, not myself, the coordinator, unfortunately. So we did not get through as much as I'd like to. So I had to kind of change the question on question number 6 to material that we could actually put in this exam. Don't worry about 6B is the point. I won't ask a question like that. I think that's just I just wanted to put an extra question in there to give you a little more practice, but that one's a little bit, I mean, that has a little calculus. I just don't worry about it. Okay, guys, I'm a little bit over time, 5 minutes over time, and I'm gonna have to make some dinner for my children. But I really want to wish all of you luck. I'm sure I'll see some of you in lecture tomorrow. But I'll be there that evening, floating between rooms. And I think everyone's going to do very, very great. Someone asked, is lecture a review? No, this is the review. We're going to keep going ahead and pretend like, you know, everything's normal. So we'll learn a little bit tomorrow on arc length. But yeah, good luck with the exam. Thanks, everybody.